Kia ora Year 10, and maybe some Year 9s, and maybe some Year 11s. This exercise goes through the next step of algebraic fractions. It goes with Gamma Chapter 1105, the first half of that exercise, because we're not factorising quadratics just yet, and that's what comes up in the second half. So I'm going to go through these 5 questions, so you might want to pause the video and just write these in your book, leaving some space in between each one. And you could have a go at doing them as well if you think you know what to do already. So the big idea here is that we're looking for common factors because that's going to help us simplify. In question 1, let's look first at the denominator. Is there any common factor in here that I can take out? No, there's not, right? So we've got an x here and we've got a 2 here. We've got no numbers that are factors and we've got no variables that are factors. But if I instead look at the numerator, I see that I've got a common factor of 5. So 5 watts will give me 5x. 5 times x will give me 5x. 5 watts will give me negative 10, or take away 10. 5 times negative 2. And the pattern that you will quickly see is that we've got a common factor here. Now we can think of that x minus 2 having brackets around it, but we don't really need them. But what we're saying is that we've got 5 times something here divided by the same something down here. And we know that if we have something divided by something, we get 1. So my final answer here is just 5. Okay, I'm going to do the next 4 questions a little bit further down, but that's the same idea that's going to work for all of these questions. It's just that the factorising gets a little bit trickier. So number 2 is one where the numerator hasn't got a common factor. There's nothing we can do to x plus 4. But the denominator has got a common factor of 3. So it's x plus 4 divided by 3 times x plus 4. Now we could put brackets in here if that helps us when we're getting started to see that we've got a common factor of x plus 4. But you might be going, well, what's going to happen because then I'm going to have nothing here? Well, I haven't got nothing. I've just got 1 times x plus 4. Right? So we've got an invisible 1. And we don't want to write that in, except the very first time we might. So that means that my answer is going to be 1/3. I did this example on purpose because lots of students kind of get confused when they see that they've lost their common factor. For example, if you had x plus 2 over 5 times x plus 2, the same thing's going to happen, right? Your common factor is x plus 2. You can simplify that out because x plus 2 divided by x plus 2 is 1, and you're left with nothing over 5, but just 1 divided by 5. Okay, on to number 3. So number 3 is a little bit different, but it's exactly the same big idea that we're looking for common factors. This time we're going to find a common factor in the numerator and in the denominator. So look what we've got in the numerator. We've got a squared plus a. So the common factor in there will be a. So a times what will give me a squared? A times a. And then a times what will give me a? 1. Okay, now let's look at the denominator. But our brain is kind of starting to think maybe I'm going to find a common factor that will simplify. Not always. Well, here we've got 3a and here we've got 3. So the common factor is 3. 3 watts will give me 3a. 3 times a. Plus 3 watts will give me 3. 1. So my common factor is a plus 1. So my final answer is a divided by 3. Question 4. 2a squared plus 8 divided by 2. Well, there's clearly nothing I can do to simplify 2. But in the numerator, always systematically look at your constants and your coefficients, right, your numbers, and see if there's a common factor here. Well, the highest common factor here is going to be 2. And then here I've got an a squared, but here I've got no a stuff. So it's just going to be 2. 2 watts give me 2a squared. 2 times a squared plus 2 watts will give me 8 2 4s. So simplifying here, 2 is the common factor. So that leaves me with a squared plus 4. Right, one last one. And I've tried to do ones that are going to help you when you go and do the first half of exercise 1105. I really like this chapter of the textbook because it just gradually increases the level of challenge. So in here there are no coefficients, there are no numbers, but we need to look at what the highest common factor is here. So I've got x to the power of 5, and here I've got x to the power of 4. So remember that this is x times x times x, and so on. And this one is x times itself 4 times. So the highest common factor in here is all of this, right? The highest common factor is x to the power of 4. X to the power of 4 times what will give me that one? Well, it just needs to have another x times in. Plus, x to the power of 4 times what gives me that? Well, we've already got it, so it's times 1. We do something similar in the denominator. So the highest common factor here will be x squared. X squared times what will give me x cubed? It'll be x. And in here, x squared times what gives me x squared? Plus 1. I'm just going to clean this up a bit so I can do the next step. Okay, so now we should be getting good at spotting the common factor. And we see that in here we've got x plus 1, and here we've got x plus 1. That leaves me with x to the power of 4 over x squared. And this goes right back to the earlier work we did last week. I've got the same base, so I can just subtract the powers. And my final answer is x squared. So there you go, quite a short video, but this exercise really tests whether you've mastered the skill of factorising, which is a really, really important one. And you need to be confident with that before we go too much further. So it's definitely worth spending a bit of time on this. If you do need some easier factorising work, if you've somehow got to 1105 and you've forgotten how to do that, do let me know, send me an email. Thanks for watching.